Hello, Professor. This is my presentation for DQ1, Topic 5. I'll share my screen now to explain my code. Okay, the codes I have here. For the first part of the assignment, I did the ice cream purchase against heat stroke to show if there's a correlation. I did these codes and I retrieved the first 10 samples for the ice cream, as well as the first 10 samples for the heat stroke. That is from this data set that I generated here. And this scatter plot, this graph shows a positive correlation between ice cream purchases and heat stroke incidence. However, even though it shows a correlation, we cannot conclude, or it is inaccurate to say that buying ice cream more will produce more heat stroke incidents. Even though there's the common factor, which is weather, that's weather is one that increases, it shows that heat increases during summer. The other example is level of education and earnings. And what I have here is this scatter plot showing earnings against education levels from these codes that I produce here. And the insights I have from this is that this shows a positive correlation. And the income indicates that on average, individuals with higher education level tends to have higher incomes. But correlation does not indicate causation. Even if there's a strong positive correlation between education levels and earning, it doesn't mean that higher the education level means higher the earning. There are other elements that needs to be considered. So that's for the first part of the assignment. For the second part of this assignment, with hypothesis testing, I did it with an example. I showed GPA against study hours. And this is the scatter plot here. And with this example, I have the correlation coefficient as 0.71, the p-value as 9.1, and it shows that it is statistically significant. And the insights from this shows that even though it shows a statistical significance here, it doesn't show causation. There are other factors that needs to be considered as well. And although hypothesis testing is valuable in statistical analysis, caution is needed in making causal inferences based only on statistical significance. Thank you. That's my presentation.